Tangency between indifference curves and budget line. We are going to take a closer look at what is happening at the point of tangency. Let's imagine two goods, coconut and leather. The budget is B as usual, price of coconut is PC, price of leather is PL. And I did a little bit of work ahead just to illustrate that tangency point between the indifference curve labeled I1 and the budget line with intercept P over PC along the coconut axis or the y-axis and P over PL along the X or the leather axis. Right here, the slope of the indifference curve is equal to slope of the budget line. At tangency, the slope of the indifference curve is equal to the slope of the budget line. Now, slope of the indifference curve is termed MUL over MUC, the marginal utility of leather divided by the marginal utility of coconuts. The marginal utility of the good on the x-axis divided by the marginal utility of the good on the y-axis. That is the slope of the indifference curve. The slope of the budget line is the price of the good on the x-axis divided by the price of the good on the y-axis. So PL over PC. Now, one little mention. What exactly is the slope of the indifference curve saying? When we write MUL over MUC, what are we saying? We are thinking of the rate at which one good is given up for the other. The rate at which one good is exchanged for the other. That's what the slope of the indifference curve is saying. So another word for slope of the indifference curve is marginal rate of substitution. At tangency, we set these two equal to one another or equal to each other. Marginal utility of the good on the x-axis divided by marginal utility of the good on the y-axis equal to price of the good on the x-axis divided by price of the good on the y-axis. So we can manipulate this tangency point to give us that equal marginal principle, where we set the marginal utility per dollar of one good equal to the marginal utility per dollar of the other good. So in your principles classes, this is what you typically look at. But it is just a manipulation of that phenomenon at the point of tangency. In case you are wondering, how do we actually get the slope of the indifference curve? I have something here that might interest you. Let's take this indifference curve, labeled I0, and the level of satisfaction there is 30. You have two bundles there, bundle V and bundle W. In bundle V, you have, let's say, 10 units of coconut and 5 units of leather. in bundle W, you have 5 units of coconut and 15 units of leather. Now, this consumer is indifferent between bundles V and W. So as the consumer, well, let me take one step back. Why is the consumer indifferent between bundles V and W? Well, it's because bundles V and W deliver the same level of satisfaction. So the consumer will either consume bundle V or bundle W and get the same level of satisfaction. So if the consumer wants to exchange bundle V for bundle W, then we see this movement along the level curve or along the indifference curve. We move from bundle V to bundle W. When we move from bundle V to W, we lose coconuts. In fact, we lose 5 coconuts. We give up 5 coconuts, or 5 coconuts given up, right? We give up 5 coconuts and we gain 10 units of leather. I'll take that again. The movement from bundle V to bundle W, we gain 10 units of leather and we lose 5 units of coconut. We have just exchanged bundle V for bundle W. So how do we capture that exchange? We capture that exchange in the slope of the indifference curve as you move from bundle V to bundle W. So how then do we calculate the slope of this indifference curve? Slope is rise over run, right? And what is on the rise? We have good Y on the rise and good X on the run. So it's a change in Y over change in X. Well, our Y here is coconut. So we have change in C over change in L. Hope you're following. And now we are going to analyze the movement from bundle V to bundle W. Mind you, the slope along a curved line is different at every point of the curve, right? Yeah. Slope of a straight line is the same at every point along the straight line, but slope of a curved line is different at every point on the curved line. So anyway, let's go on. To characterize that exchange, that movement from V to W, and therefore the slope of the indifference curve, we have to note that as we move from V to W, there is no change in the level of utility that is delivered by this level curve or by this indifference curve. So the change in satisfaction is 0. Right? Change in utility is 0. This U here represents utility. Change in utility is 0. All right, so what about this stuff? What is it? Well, as you move from bundle V to bundle W, there is a change in coconut. And I put some numbers there so we see that we give up 5 coconuts, right? So there's a change in coconuts. Good. Okay. Along with that decrease in the number of coconuts we consume, there is also the marginal utility that's now delivered to us. Remember, as you consume more of a unit, marginal utility falls. Now in this case, we are consuming less coconut, so marginal utility in coconuts should go back up, right? So anyway, we record the associated marginal utility in coconuts for the decrease in coconuts consumed as we jump from bundle V to bundle W. At the same time, what is happening? We are consuming fewer coconuts, but we are consuming more units of leather. See? So that's the change in leather here. Associated with that increased consumption of leather is the marginal utility of leather. Marginal utility is such that it slopes downwards. As you consume more of a unit, marginal utility falls. So we record that associated marginal utility. And of course, there is no change in the level of satisfaction that this indifference curve gives us. It's going to be 30, right? There's no change. It stays at 30. So when I say there is no change, 30 minus 30 is 0. No change in utility. So all of this is set equal to 0. Meaning, the level of utility you got when you were at bundle V is the same level of utility you have at bundle W. And so the difference between the level of utility at these two bundles is 0, right? So that's what we have. Now, mind you, we said slope is characterized as change in C over change in L. Change in coconut over change in leather. Change in the thing on the y-axis divided by change in the thing on the x-axis. So we are going to rewrite all of this with change in C over change in L on the right-hand side. Let's do that. So I set all of this equal to 0, like so, and then I move the change in L to the right-hand side, pardon me. And then I divide through by change in L to get rid of this change in L over here. And then I need to divide through by marginal utility of coconut, right? Do you see that? Okay. So I do that to cancel it out. And there we go. On the left-hand side, I have this as I wanted. And so that gives me change in the thing on the y-axis divided by change in the thing on the x-axis is equal to marginal utility of good L over marginal utility of coconuts. So the slope of the indifference curve is this stuff. And this, or the absolute value of this, is the marginal rate of substitution, the rate at which coconuts are substituted for leather while maintaining the same level of satisfaction. Remember, when we jumped from bundle V to bundle W, the level of satisfaction didn't change, right? So that is an important part of this. Otherwise, we will not be able to get this stuff out here. So in the slope of the indifference curve, we are consuming more leather and giving up coconuts while maintaining the same level of satisfaction. This is what is happening at the tangency point, at least in terms of the slope of the indifference curve, right? This is how we get the slope of the indifference curve. So let's go back up. Let's go back up. Here, at tangency, we set the slope of the indifference curve equal to the slope of the budget line. And if you need a reminder on slopes of the budget line, please see previous videos. I have them there. We set these two equal to each other, and we see the optimal number of coconuts and the optimal number of leather units that this consumer will consume. I hope this helps you at least see a little bit of the math that is going on. By the way, let me go back down. The math here is partial or implicit differentiation along a level curve. Okay. I hope this helps you. Like and subscribe. If you have any questions, write them in the comment section. If you take my classes, please just come to office hours. Have a good day. Bye-bye.